So friends, we have completed the task of input supply. Remember these terminals? The earthing wire of the input supply main, that's here. The neutral terminal of the energy meter, that's here. The output terminals of the isolator cutout box, that's here. We will be connecting these wires to the distribution box and also wire the distribution box in this session. Join me. After completing this session, you will be able to do the wiring of the distribution box. We need to design the distribution box, which we will design on this wooden board. Step 1.
Keep the required components ready.
For making a 3-phase distribution box, we will need the following components. 3 bus bars, 1 for each phase, R, Y and B. MCB box, TPN switch, MCB switches of 32 amps, MCB switches of 16 amps, wiring cables of 2.5 square mm, 2.5 square mm wire lugs. Step 2.
Keep these tools handy.
We will need these tools. Screwdriver, drilling machine, measure tape, wire stripper, spanner, cutter. Step 3. Identify the number of 32 amp and 16 amp MCB switches required for each room of the house. The kitchen requires one 32 amp MCB and one 16 amp MCB. The living room requires one 16 amp MCB. Bedroom 1 requires one 32 amp MCB and one 16 amp MCB. Bedroom 2 requires one 32 amp MCB and one 16 amp MCB. The bathroom requires one 32 amp MCB. The corridor requires one 16 amp MCB. Thus, we require 4 32 amp MCB and 5 16 amp MCB in total. Step 4. Identify each phase and then dedicate them to each room based on the load distribution. Our preparation also includes distributing the phase as per the rooms. In order to equally distribute the load across 3 phases, we must identify each phase and then dedicate them to each room based on the load distribution. In this case, the kitchen is dedicated to the R phase, the living room is dedicated to the Y phase, the bathroom is dedicated to the Y phase, the corridor is dedicated to the B phase, bedroom 1 is dedicated to the B phase, and bedroom 2 is dedicated to the B phase. So now we are ready to start the designing and wiring of the distribution box. Step 1. Wear the personal protective equipments. Switch off the main input supply. Step 2. Mark the area for fixing the MCB on the distribution box. Using drill machine, drill holes on the marked locations. Using suitable screwdriver, then fix the MCB boxes on the wooden board by tightening the screws. Then fix the TPN switch in the MCB box. Press the lock available on the TPN switch and lock it with the MCB box. Step 3. Take MCB switch mounting panel and mark the locations on the wooden board. Using drill machine, drill holes on the marked locations. Then fix the panel on the wooden board by using screwdriver. After fixing the panel, fix all the MCB switches on it. Press the lock available on the MCB switch and lock it with the panel. Step 4. Similarly, mark the areas for the 3 bus bars. Step 5. Using a drill machine, drill holes in the marked locations for all the bus bars. Step 6. Now fix the bus bars on the distribution board with the help of screws.
Step 7. Fix the neutral wire connector on the MCB switch panel.
We have now completed the assembly of components in the distribution box and it is ready for wiring. Step 1. Connect the output terminals of the isolator cutoff switch to the input terminals of the distribution box through the MCB. First connect red, yellow and blue wire in the R, Y and B phase output terminals of isolator cutoff switch. Then connect the R, Y and B phase output of cutoff switch to the respective R, Y and B inputs on the TPN switch. Then take the black neutral wire from the energy meter neutral output and connect it with the input neutral terminal on the TPN switch. After that, connect the earthing wire of the input supply main to the earthing terminal in the MCB. This is how input mains supply connects to the distribution board. Step 2. Now connect the output terminals of the TPN switch to the bus bar of the respective phase. Firstly, connect the wires in the RYB and neutral output terminals of TPN switch. Now let's connect the other end of all the phase wires to their respective phase bus bars. To connect it, take a 2.5 square mm wire lux and connect it at the stripped ends of all the phase wires by using plier. Then take red wire and connect it to the input terminal of red phase bus bar by tightening it with the nut and screw. Similarly, connect the Y and B phase wire to their respective phases bus bars input terminal. Now take the neutral wire from the output of TPN switch and insert it into the input of wire connector. Step 3. Connect all phase bus bars with their respective MCB switches. Firstly, connect the red wire on R phase bus bar output terminal. Similarly, connect the yellow and blue wire on Y and B phase bus bars output terminals. Now we have to connect the other ends of all the phase wires with their respective MCB switches. For R phase, we are using two MCB switches, one of 16 amp and one of 32 amp. Firstly, insert the wire from output of R phase bus bar to the input of R phase 16 amp switch. Step 4. Now we have to connect the 32 amp R phase MCB switch with the R phase bus bar. For this, interconnect the 16 amp switch with the 32 amp switch. For that, take a cut piece of red wire. Insert one end to the input of R phase 16 amp switch and other end to the input of 32 amp R phase MCB switch. The same is to be repeated for Y and B phase bus bars, one 16 amp and one 32 amp switch for Y phase and three 16 amp and two 32 amp switches for B phase.
So what you see here is the MCB switch distribution for the various rooms as per the table.
Step 5. Check all the connections to ensure there are no loose connections. So, friends, this completes our designing and wiring of distribution board with the input main supply. Earthing wire from MCB, phase wire from the MCB switches and the neutral wire from the output of wire connector will be further connected to the switch boards of their respective rooms. This part we will see in the next session. Now you know the process of distribution board wiring. Let us see a block diagram and do a quick recap of the wiring from the start point. The very first step is to connect the main input supply to the fuse box. Next, the fuse box to the energy meter, which in turn is connected to the fuse cutout switch. The fuse cutout switch is then connected to the distribution box through the MCB. Inside the distribution box, the MCB outputs are connected to the MCB switch inputs through these bus bars. The MCB switch outputs will now be connected to the switchboard, which we will see in our next session. That was quite a task, and I'm sure with the recap, you must be ready for the test. Best of luck, guys. Read the questions and click on the correct answers.